welcome. And if you're watching this video, I highly suspect that your truck is doing what my truck is doing, which is driving straight across the bridge that we designed ourselves. Congratulations. Now, that's all fine and dandy, but let's stop the truck in the middle of the bridge for a moment. So push the pause button up here. And this will give us an idea of where the forces are acting on the different members in our trusses and whether or not we can reduce their size. So wherever you see a nice dark color, that's actually what we want to see, because that's telling us that our material is reaching its limits before breaking. And where the color is very light, whether kind of pinky or bluey, there's less force acting on that particular piece, and it can be reduced in size probably. So all of these light colored pieces, and there's quite a few of them, we can make smaller in most cases. We'll have to do some testing. But let's go back to the drawing board now, and we're going to write down a few numbers. So the first number is the iteration count, which is right up here. And that tells us how many times you tested the bridge before it worked. So in my case, it's 15. And whatever number you've got, write that down on your sheet for design 1, which is movie number 2. The second number is how many members make up your bridge. And that's easy because we just have to go over to our table, scroll down to the bottom, and the very last number is how many members you've got. So in my case, I've got 35. Last thing we're going to jot down right now is the cost of the bridge at this point. And for me, it's $370,634.31. But whatever you've got up here, you're going to write that down. Now 370 actually isn't too bad. If you're over 500, you're going to have some work to do. That just makes it more fun. Instead of remembering what the colors were like when we parked the truck on the bridge, there's another thing that we can do to see the results. And that's clicking this button up here. This shows us a table of the load test results. It's a little bit similar to what we see here in this table. But if we click on that, we get some really interesting numbers here. So let's just focus on the first member. And if we take a look, we can see that it's carbon steel. There's the carbon steel setting. It's a solid bar. It's 140 millimeters. And the length is 4 meters. Now that's not obvious by looking at it, but there we go. Now we know. Slenderness number, don't worry about that too much, but the higher the number, the more slender it is, and the more likely it's closer to its limit. But we can see that right now there's 0 compression force on that piece. And the compression strength is pretty high compared to the force. If we take a look at tension, there is some tension, but still it's way stronger in tension than the force that's being applied. So we know right away that we can reduce the size of number 1 quite a bit because it's way stronger than the forces that are acting on it. Let's take a look at number 2. Again, carbon steel. They're all probably the same because unless you changed it. But the size is different. It's 170 in section, but it's a lot longer, 12 meters. And so it has a higher slenderness number. But it is under compression. We see that there's a number there. And this is actually kind of what we want to see. We want to see that it's about double the compression force. And then we know that we've got a safe bridge. So that's pretty close. If we take a look at tension, there is some tension, but not anything compared to the strength in tension. And that's going to be pretty common, that it's going to be stronger in tension than it is in compression. So this may be the number to deal with mostly. It all depends on what's happening. So if you go through looking at your compression force relative to your compression strength and your tension force relative to your tension strength, just look for the low numbers, and that's going to be the place where you can reduce it the most. All these things here. Where you see that they're pretty close, like less than half difference, like number 11 here and number 12, those ones are, you probably don't want to touch at all. They're just about right. This one could be reduced a little bit, that's a lot, and so on. One thing that you might want to start with, though, is thinking about reducing the number of pieces that you have in your bridge, and maybe even the placement of joints. For instance, if you happen to have built anything on top of the bridge and below the bridge, like I'll just add a little piece here, if you've got something like this, for sure it's overbuilt. For this particular bridge, you do not need 2 layers of truss. That's just too much. And we can see from our foundations that, and with these joints anchored on the bottom, that this is designed to be an under the roadway truss. There aren't any supports on top, which would indicate that it would be an above the roadway truss. So anything above the road, remove. Not necessary. So if you've done that, take out anything on top and test again. And you may need to adjust a few pieces down here if they break, but I'll bet you they won't. And if you've got that working and it looks, something like this one, what you might want to try doing is playing with the joint placement. We want to make a kind of arch shape because we know arches are strong. And if we do the same thing with our truss, we get the benefit of an arch and the benefit of a truss. And the middle part of the bridge can be, generally speaking, a lot thinner than the ends of the bridge. So again, I want to be symmetrical, but if I do something like this to make an arch shape, there we go. Whoop. Maybe like that. And this one down here. Let's test that and see what happens. Now, because I've changed my truss, there's going to be some pieces that might break. So you might have to go back and look, it's only 2 pieces. So I'm going to click on the first one, hold down the control key, and click the second one, and I'll adjust them the same. So let's make them bigger. I'll go to 160 and see. That's going to do it. And don't worry that it looks like the bridge is really sagging and whatever, because remember, that's the exaggeration. We can turn off exaggeration. For the most part, we get some darker colors in these parts, but the middle part still doesn't look like it's that stressed out. We can reduce some of these things again. So let's go back to the drawing board. We should probably open up our load test results again and compare the numbers. So number 1, still 0 and still really strong, more tension, but it's like 10 times stronger than it needs to be. That doesn't mean you make it 10 times smaller, but we can make that one less. Let's start with number 1, and if we click on it in the table, we'll see where it is. Being symmetrical, we want to select the opposite one. Because these ones are in tension, we have 0 compression, we likely want to change it from solid to hollow. Things in tension are fine to be hollow. Things in compression, we may want to be solid because that's stronger. And we could do another quick test, and I can see that that's going to work. It is darker than it was before. Just by making it hollow, we've saved a bunch of money, and we've also saved a bunch of money from just moving the joints around. Go ahead and keep playing around. You can also try playing with the different types of alloy. So let me just select both of those. We've been using carbon steel. That's the cheapest, but it's the weakest. Here's the next strongest and next most expensive, and then the very most expensive and the strongest. So if we change the material and do a test, you can see that it's going to work. But look at that. The color's not nearly as dark as it was before because it's much stronger. I'll bet we can get away with changing the size, and it still works, and still quite light colored. Try changing your materials, changing from solid to hollow for tension tubes, and keep adjusting until you get this value down as much as possible. Keep going, and when you've got a working bridge and you think you can't go any further in cost reduction, watch the next movie.